Let's do part B, word problems. Number 6, how many ways can the first 3 prizes be awarded in a race of 10 participants? So again, this is permutation. So since we are choosing 3, what we can do is simply 10 times 9 times 8. That should give us 720 as our answer. Number 7, a password consists of 3 letters chosen from A, B, C, D, E without repetition. So again, 3 letters. 1, 2, 3. First, first part or first entry, there will be 5 choices. And then since without repetition, so since we already took 1, so the remaining will be 4, and then the remaining will be 3. That is just 5 times 4 times 3. And again, number 7 will just gonna give us 60 as our answer. Number 8, a sports team wants to select captain, vice captain, and manager from 7 members. So again, we are choosing captain, a vice captain, and a manager. So we are choosing 3. So this is again permutation. 7, choose 3. This is just 7 times 6 times 5. That's gonna give us 30 times 7. That's 210. Number 9, how many ways can 4 different trophies can be arranged on a shelf? So again, there are 4, we choose 4. So permutation 4, choose 4. This will give us 4 factorial, or 4 times 3 times 2 times 1. And again, this will give us, this is 12, 24. That's 24 ways. Number 10, in a photo, 5 students are to stand in line for a picture. So again, in a photo, 5 students are to stand in a picture. So again, this is permutation. The order matters. So this is again 5, choose 5. 5 permutation 5, or simply 5 factorial, or again 5 times 4 times 3 times 2 times 1, which is, this is 20, 60, 120 arrangements in total. Letter C, word problems still, but this time we are doing combinations. So from 12 candidates, choose 5 to form a committee. So again, we are doing 12, choose 5. So this is just what? This is 12 factorial over, we are choosing 5, so we have 5 factorial and 7 sorry, factorial. That's 12 minus 5, that is 7. Again, this will gonna give us 792. Right, this is 792. Let me just grab the calculator just to be sure. This is 12, choose 5, right? That's 792. Number 12, a teacher selects 3 students from 8 for a project. So again, this is 8, choose 3. This is 8 factorial over 3 factorial, 5 factorial, or this is 8 times 7 times 6 times 5 factorial over 3 factorial, 5 factorial, and again, this will be cancelled. That one. So this gonna gives us 8 times 7 times 6 over 3 factorial, and we know that we know that 3 factorial is 6. So this will be cancelled. So that is just 8 times 7. This is 56. Or again, using our calculator, we're gonna say we are choosing 8, right? 8, choose 3. So this is 8 combination 3. That is indeed 56. All right. Number 13, choosing 2 books from 6 for reading. So again, this is 6, choose 2. This is 6 factorial over 2 factorial 4 factorial. And again, you don't need to remember the formula. All you have to do is when you're doing combination, just make sure that the denominator here, the numbers will add up to 6. So again, since we're choosing 2, of course, that is 2 factorial. And again, since this is 6, we need 4 more to give us 6, right? It's 2 plus 4 is 6. So this is just 6 times 5 over 2 factorial, or simply this is 15. Number 14, selecting 4 players from 15 for a volleyball team. So again, this is 15, choose 4. So this is 15 factorial. You're choosing 4, so 4 factorial. We need how much more to reach 15? 11 factorial. So that is 15 times 14 times 13 times 12 times 11 factorial over 4 factorial 11 factorial. So let me just grab my calculator. So this is 15, choose 4. This gives us 1,365. So this is 1,365. Nice. Number 15, choosing 3 flavors of ice cream from 7 available. So again, this is 7, choose 3. This is 7 factorial over 3 factorial times 4 factorial. This is 7 times 6 times 5 times 4 factorial times 3 over 3 factorial and then 4 factorial. This cancels out. So you are left with, we know that 3 factorial is 6, so this is actually canceled out. You're gonna have 35. All right, let's do number 16. I will focus more on, let's say, 17, because this is a bit interesting. So I leave this 16 for you guys to answer, and then the rest of the numbers. From a letters of the word mathematics, how many 4-letter arrangements can be formed if letters are not repeated? So identify whether it's permutation or combination. So again, since we are doing arrangements, this is permutation. Now, we are asked to form a 4-letter word or arrangement. Letters are not repeated. So we cannot do, say for example, AA, that's not allowed because again, letters are not repeated. So if you're going to look at our word mathematics, there are actually letters that are repeated. We have M, we have A, and of course we have T. So what we are going to do is we are not going to consider all of the letters here. We are only gonna consider the unique letters. So there will be how many unique letters? In mathematics, there are 11 letters, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. But then again, there are repetitions. 1, 2, 3. So meaning to say there are only 8 unique letters, and we are choosing 4. So that will be our setup. So we have 8 permutation 4. So this gives us 8 permutation 4. That is 1680 or 1680. And then a challenge question for you. Number 20. It says here, a password is formed using 2 letters from A to F and 2 digits 0 to 5 with no repetition. Identify whether it's permutation or combination and compute the total. That will be your task. Peace.